Hi, today we are diving into chapter 25 of Clean Architecture, Layers and Boundaries. Most developers think of architecture as just three circles: UI, business rules, and database. But as Robert C. Martin explains, real-world systems are far more nuanced. In the next couple of minutes, we will explore how to identify and draw boundaries that keep your systems flexible and maintainable using a modern smart home ecosystem as our guide. It's a common trap to assume that every system is just a UI talking to business rules that talk to a database. While this works for a Hello World app, it fails for anything complex. Architectural boundaries aren't just about technical tiers, they are about axis of change. If we only have three layers, we force unrelated changes to collide. We need to look deeper to find the true lines of separation that allow our components to evolve independently. Let's look at a smart home hub. At its core, we have the automation engine. This is the high-level policy that knows when to turn on the lights. Surrounding it are various streams: the UI for the user, the persistence for device states, and the external integrations for sensors. By using this example, we can see how boundaries naturally emerge when we consider how the system might grow. The first boundary we draw is between the automation engine and its input-output. The engine shouldn't care if the user is using a mobile app or a voice command. It also shouldn't care if the device state is stored in a local flash chip or a cloud database. We define APIs that the engine owns, and the UI and the persistence components implement those APIs. This is the essence of dependency rule. Dependencies point towards the higher level policy. In the book, Uncle Bob splits the UI into language and text delivery. In our smart home hub, we can split the UI into user intent and protocol delivery. The intent component understands turn on the kitchen light, while the delivery component handles whether that came via a Zigbee switch, a Wi-Fi app, or a Bluetooth remote. This boundary allows us to add new hardware protocols without ever touching the logic that interprets what the user wants to do. Just as we decouple the UI, we also need to abstract how and where we store data. This is the persistence axis of change. The automation engine shouldn't care if data lives in RAM or a cloud database. We create a boundary so the engine simply asks to save state, and the persistence layer handles the details. This keeps our core logic clean and independent of storage technology. It allows us to swap out storage solutions without rewriting our core business rules. Now, let's look at how different data flows converge within our system. Systems rarely have just one input and one output. They have multiple data streams converging. In our smart home hub, we have distinct streams like sensor data, user commands, and outgoing device instructions. Each of these streams represents a different path of information. Recognizing these as separate streams helps us manage complexity. It means a flaky sensor won't directly impact how a user interacts with the system. But even within these streams, we find further distinctions. Even our core logic isn't a single monolithic entity. It splits into different levels of policy. We have high-level automation rules like if motion, then turn on light, and then the lower-level device mechanics which know how to dim a specific brand of smart bulb. These are distinct levels of change. By drawing a boundary here, we protect our valuable automation logic from the constant churn of new hardware. Sometimes these boundaries become so critical They require physical separation like with microservices. Imagine our hub offloading complex tasks such as energy optimization to a dedicated cloud service. This creates a network boundary. The hub sends raw data and the microservice returns optimized schedules. This isn't just a logical separation, it's an enforced one, preventing accidental dependencies. This physical separation is the ultimate form of decoupling. So how do you actually find these crucial boundaries? You hunt for change. We just saw how microservices create physical boundaries, but the principle is the same for logical ones. Look for things that change for different reasons or at different rates. The UI changes because of user preference, while hardware drivers change due to vendor updates. Each of these is a strong candidate for a boundary. Your job as an architect is to recognize these early, but remember, implement them only when the cost of not having them exceeds the cost of building them. In summary, this chapter teaches us that boundaries are everywhere. We have explored how to identify them in our Smart Home Hub example. By following the dependency rule, we protect our core business logic. We treat UI and databases as mere plugins, easily swappable details. This approach, driven by recognizing different axes of change, creates a system that's easy to test, deploy, and evolve. This is the true power of clean architecture. Now it's time to implement. Start by identifying the axis of change in your own projects. Where do things change for different reasons? Next, define clear interfaces for your most volatile components. This creates those crucial boundaries. Finally, pick one input-output stream in your current project and refactor it into a plugin this week. This small step will show you the immediate benefits of decoupling. And with that, we are almost at the end. In conclusion, remember, don't just draw lines because you can. Draw them because they provide the freedom to evolve your system. If you love this content, please like, comment, share and subscribe for similar content in the future. See you in another video. Until then, elevate.